This is a worksheet about similar triangles, and in this case notice these two are marked the same, so that is an angle bisector. That means the corresponding sides have to be in a ratio. So I'll do top to bottom. 24 is to 3x minus 1, as I think that's an 18, is to 2x plus 1. So I'm going to cross multiply 2x times 24, 48x plus 24 equals 3x times 18 is 54x minus 18. I will subtract 8x from both sides. That gives me 6x. Add 18 to both sides. And what's that? 42. X equals 7. And it asks to find x. So that was 20. Here's 21. Again, that's a bisector, angle bisector. So that means the corresponding sides are going to be in the same ratio. So 6x plus 2 over 8 equals 9x minus 2 over 10. I did left to right. And so now I will cross multiply 60x plus 20 equals 72x minus 16. I will add 16 to both sides, subtract 60x plus from both sides. 36 equals 12x. X equals 36 divided by 12 is 3. Well, here's another one, and this one, I'm looking at these numbers. This has 2 tick marks. This is 2 tick marks. This is 2 tick marks. So this is 16. And I'm looking at these numbers, and it's not going to come out even, but I'm going to check it. I'm going to do top to bottom. I'm going to do the slanties. 21 is to 16 to the straights. 16 is to 2x plus 6. 2x cross multiply. 21 times 2x plus 6 is 40. 2x plus 126 equals 16 times 16 is 256. 42x equals 130. See, I'm telling you, this isn't coming out even. Equals 130 over 42 equals 65 over 21. That's not even, but that's the answer. I guess you can use your calculator to find out exactly what that is. What's 3 point something, 3.1-ish? It's very strange, though. All right, those are equal, so that makes this a angle bisector. That means segments are in a ratio. This is 54, 28, 28, 38, 48. This is 24, this part here. So I'm going to again do top to bottom. See how these other ones are coming out even, but that last one didn't, which I don't know. There might be some, I might be reading numbers wrong. It's a little bit blurry. So I'm doing top to bottom. X minus 4 is to x as 24 is to 28. I will cross multiply. 28x minus 112 equals 24x. Subtract 24x from both sides, add 112 to both sides. 4x equals 112. X equals 832. 4 times 8, x equals 28. And I think it's on. Well, that's very strange. Did I do that right? Oh, that's not x minus 4. It's x minus 5, isn't it? Why didn't someone correct me? Okay, hold on. I've got the wrong numbers here. That's supposed to be x minus 5. I better check all the other ones. X minus 5 equals 24. I'm just going to write it all. Ugh, what is this doing? Hold on, it was going wacky. All right, x minus 5 over x equals 24. I don't know why there's a 3 there. That's probably a remnant of my calculating, and the rest of this I'll get rid of. It didn't look right just because of the way it's drawn, but then I notice x minus 5. All right, 28 times x minus 5 is 28x minus 5 times 8 is 40. Just 10, 140. Yeah, 140 equals 24x. Now I will subtract 24x from both sides. 4x equals 140. X equals 4 times 3 is 12. Is 20. 4 times 5. X equals 35. That looks better. Okay, x is 35. All right. Now, this one says find the missing coordinate. And I guess everything has to be in proportion. ABC. ABC, the little triangle, is similar to AYZ, to the big triangle. So everything has to be in proportion. So this is 0, that's 4. And then this is 0, 8, so that's 4. So those are the same. This is 0, 0 to 6, 0, that's 6. Well, if it's the same up there, it's the same up there. It's going to be 6 there, so it's going to be 12, 0. It has to be the same. All the proportions have to be the same. I guess I'll do this one next. Hold on. This is 4, because it goes to 4, then goes to 12, which is 8. I don't know what this is. I know this whole thing is 6. It goes 6 down. This whole thing is 12. So now I guess I can find it. I want to find the coordinates of B. So I'll put that distance, I'll just call it B. The distance is B over 4. I'm using the left to the top, left to top. B over 4 equals a total of 6 to 12. So 12B equals 24. B equals 2. So this is 2, which would make this 4, which makes sense. 4 times 2 is 8. 2 times 2 is 4. Okay. Got that one. Now, a rectangular... Why can't I get this zoomed in to where I want it to be? Okay, I want it right in the center. Rectangular postcard has the dimension shown below. Michael used a photocopier to make a postcard that is similar to the one shown, but with a length of 7.5 inches. Well, the length of this is 6, so it's 6 to 7.5. I'll just double them both. That's 12 to 15. I can divide both of them by 3. What is the scale factor of the dilation? Oh boy. Did he make it bigger or smaller? Well, I made it bigger. So I guess I have to do 7.5 over 6. 7.5 over 6 equals 15 over 12 equals 3 goes into 15 5 times, 3 goes into 12 4 times. So it says photocopier. Yeah, so the photocopier had to make it bigger. So it made it 5/4. It multiplied the 6 by 5/4. What was the scale factor of the dilation? 5/4. D. A dilation can be an expansion or a contraction. Let me look it up just to be sure. Dilation is an expansion or contraction. If you're not sure, look it up. Just like dilation can be the expansion, enlargement, or contraction. Reduction, yes, okay? So I put this card in the photocopier and it made it bigger. So I've got to have the 5 on top, and that's D. All right, next one. I guess it's this one, and I looked this one up. There's a problem with this image. And this one, I'm going to draw the whole thing in red. So it looks like this. This is B, and this is C. So you can see the bottom of A is 1, the bottom of B is 2, the bottom of C is 3. I actually didn't draw that one right. It's supposed to be right to there. Don't want to make it look bad. Okay, which of the following describes the dilation? Dilate A with a scale factor of 2. That gives me B, yeah, because it goes 2 high to 4 high and 1 across, 1 wide to 2 wide. But then this one says, then dilate B with a scale factor of 2. Well, C doesn't have a base length of 4. It has a base length of 3, so that's not it. Dilate A with a scale factor of 3, then C with a scale factor of 1/2. Okay, so A to C is times 3. That's 1, 2, 3, 4, 5, 6 up, 1, 2 up. Yeah, so that's times 3. But then this would be, if I go 1/2, I would be 3 up. 1, 2, 3, 4. So that's not it. That's 4 up. No. Dilate A with a scale factor of 2. That would get me B. 2 times 2 is 4. Then dilate A with a scale factor of 3. So A times 2 is B, yes. A times 3, 3, and 2 times 3 is 6. 1, 2, 3, 4, 5, 6. Yes, if I dilate A with a scale factor of 2, I get B. And if I dilate A with a scale factor of 3, I get C. So that one seems to work. And then dilate A with 2, then dilate A with 4. Well, no, because C is not 4 times A. It's only 3 times A. So the answer is H.